Welcome to the Fresh Thinking School of Brain Science. Today, we will discuss one specific branch of neuroscience called cognitive neuroscience. Cognitive neuroscientists are explorers of the mind. They bridge the gap between the physical brain and our intangible thoughts, emotions, and experiences using brain imaging, behavioral studies, and computational models. Cognitive neuroscientists seek to understand how the brain's intricate networks give rise to perception, memory, decision-making, and even our sense of self. Their discoveries shed light on the fundamental nature of what makes us human. Cognitive neuroscientists can peer into the living brain thanks to revolutionary imaging tools like functional magnetic resonance imaging and electroencephalography, EEG. They are investigators of the mind who bridge the gap between our tangible biology and the intangible world of thought. They meticulously study the intricate workings of the brain to uncover the secrets of how we perceive, learn, remember, make decisions, and experience emotions. At the heart of their work lies the fundamental question: how do the brain's physical structure, billions of neurons, and intricate networks give rise to the complex spectrum of human cognition? The work of cognitive neuroscientists is essential in several areas. Understanding the mind. Cognitive scientists' discoveries have revolutionized our understanding of the human mind. By peering into the living brain, they have begun to unravel the biological basis for our most complex experiences. Here is how their findings are transforming our view of what it means to think and feel. Mapping the mind. Brain imaging has fundamentally changed how we understand the most complex organs in our bodies. These technologies reveal that our brains are dynamic landscapes. When we think, feel, or act, specific regions light up with activity. The amygdala, for instance, is vital in our fear response, while the hippocampus is essential for forming new memories. This shows the brain as far more than a homogeneous lump of tissue. It is an incredibly specialized organ with distinct areas handling different tasks. Yet, the brain's true power lies in connection. These specialized regions form a vast interconnected network. This constant communication underpins the incredible range of our thoughts, emotions, and behaviors. Emotions demystified. Emotions were once shrouded in mystery, but cognitive neuroscience is turning that around. Researchers reveal that emotions aren't just an abstract feelings. They have a biological basis in the brain's complex circuitry. By studying the release of neurotransmitters or chemical messengers, scientists connect emotional states to specific brain activity. For instance, dopamine is crucial in our feelings of reward and pleasure, helping illuminate the brain mechanisms behind motivation and positive experiences. The influence of experience. The brain has an extraordinary ability to adapt and change throughout our lives called neuroplasticity. It means our brains aren't set in stone. Learning a new language or new skill, practicing a musical instrument, or even engaging in psychotherapy can create new neural pathways and strengthen existing ones. Neuroplasticity shows that the brain is dynamic and constantly evolving in response to our experiences, unlocking disorders. Cognitive neuroscience is transforming the way we approach mental disorders by pinpointing specific brain areas and networks that malfunction in conditions like depression. Scientists can identify biological markers for these disorders. This precision helps replace guesswork in diagnosis with objective brain-based methods. Furthermore, it guides the development of new treatments designed to directly target the root cause of these conditions within the brain, offering hope for better outcomes. The self unraveled. Even the age-old question of what defines our unique identities has roots in neuroscience. Studies suggest that our sense of self might emerge from a complex network of interacting brain regions rather than any isolated area. This highlights the brain's remarkable ability to generate something as profound as our self from its interconnected net structure. These examples are just a glimpse into the power of cognitive science. It studies the biological underpinnings of our thoughts, emotions, and behaviors. With each discovery, the field sheds light on the brain's complex workings. More importantly, it reveals insights about what makes us uniquely human, from our personalities to our profound sense of self. Diagnosing and treating disorders. Cognitive neuroscience research is transforming our approach to understanding and treating complex brain disorders like Alzheimer's, depression, or schizophrenia. Researchers are developing more targeted diagnostic tools and therapies by pinpointing the brain regions and networks affected by these conditions. These advancements offer hope for improved outcomes and a better quality of life for those with this debilitating illness. This is how precision diagnosis. Brain imaging allows for early detection of subtle changes associated with conditions like Alzheimer's way before severe symptoms appear. This leads to earlier and more effective interventions. Similarly, neuroimaging can differentiate between types of depression, aiding in selecting the most suitable therapy. Understanding the root cause. Instead of just treating symptoms, cognitive neuroscience uncovers the underlying brain mechanisms. For example, pinpointing disruptions and reward circuitry in depression helps develop treatments targeted that dysfunction, tailored treatments. Research reveals that different people respond differently to different therapies. Brain-based biomarkers help predict who will likely benefit from a particular drug or therapy, enabling a personalized medicine approach. New frontiers. Neurostimulation techniques like transcranial magnetic stimulation, TMS, directly target problematic brain areas with magnetic pulses, offering the potential for non-invasive treatment of conditions like depression, combating stigma. Providing disorders have a biological basis helps reduce stigma. It emphasizes that these conditions are real illnesses, not personal feelings, encouraging people to seek help. While there is still much to learn, cognitive neuroscience discoveries bring hope for improved outcomes for individuals living with neurological and psychiatric disorders. This research leads to the development of more targeted, effective treatments and a greater understanding of these complex conditions. Advancing technology. The field of cognitive neuroscience inspires the development of revolutionary technologies like brain-computer interfaces and artificial intelligence systems. By studying how the brain processes information, learns, and makes decisions, neuroscientists provide the blueprints for building intelligent systems that mimic human capabilities. Cognitive neuroscientists venture into the fascinating territory where the physical brain meets the intangible mind. Their quest is to decipher the biological basis of our thoughts, feelings, and the essence of our conscious experience. Through this exploration, they seek to unravel how our brains give rise to rich tapestry of the human experience. Here's a deeper look into what they study. Mapping the mind. Cognitive neuroscientists wield an impressive arsenal of brain imaging tools to unlock the mysteries of the mind. Functional magnetic resonance, fMRI, and electroencephalography, EEG, stand out, providing unique windows into the living brain. fMRI tracks changes in blood flow within the brain, revealing which areas become active during different tasks. This helps researchers map the neural networks responsible for everything from language processing to emotional responses. On the other hand, EEG directly measures the brain's electrical activity using electrodes placed on the scalp. Its exceptional temporal resolution allows researchers to track brain activity in real time, revealing the rapid-fire dynamics of thought processes. Together, these technologies offer unprecedented insights into how our brains function, paving the way for breakthroughs in understanding mental health, neurological disorders, and the very nature of consciousness. Functional magnetic resonance imaging is a powerful tool that has revolutionized our understanding of the brain. Here's how it works. When a brain region becomes active, it requires more oxygen, leading to increased blood flow to that area. fMRI detects these changes in blood flow. By tracking these changes, while a person performs specific tasks, researchers can see which brain regions become more active. This allows scientists to create detailed maps linking brain areas to functions. For example, if the area responsible for language lights up during a reading task, it reinforces our understanding of its role. fMRI helps us understand the intricate workings of the brain, illuminating how different regions support our thoughts, emotions, and behaviors. EEG is a powerful tool for decoding the rapid-fire communication within our brains. EEG picks up the brain's minute electrical signals by placing sensors on the skull. This allows researchers to track brain activity millisecond by millisecond as it unfolds. This incredible precision is vital for understanding lightning fast processes like language comprehension. When we read a sentence or engage in conversation, our brains rapidly process not just the individual word, but grammar, context, and subtext. EEG allows scientists to track the cascading brain activity involved in these complex tasks. It reveals how different brain regions collaborate in real time to turn sounds and symbols into meaning. This knowledge helps us understand the very building blocks of communication, reveals potential targets for treatment when these processes are disrupted. Charting the neural landscape. Brain imaging tools like fMRI and EEG have revolutionized cognitive neuroscientists' understanding of our brains and our minds. It is like switching on a flashlight in a dark room. They can watch their brain in action. Armed with this power, they have created detailed maps of how the brain functions. Specific areas responsible for processing our senses have been identified. Regions that light up when we see, hear, or touch. The hippocampus has been pinpointed as memory headquarters, playing a pivotal role in storing experiences. The prefrontal cortex, the brain's executive center, is essential for complex problem solving and planning. These are just a few examples of how our understanding of the brain has changed. Networks, not just regions. Cognitive scientists, neuroscientists, have moved beyond simple mapping isolated brain regions. They are now exploring the dynamic interplay between vast networks and interconnected areas. This is essential because complex functions like perception, problem solving, and even consciousness don't happen in a single spot. They arise from the coordinated dance of multiple brain regions working in concert. Using advanced imaging tools, researchers can see how information flows, how brain areas synchronize, and how networks reconfigure in response to different tasks. This offers an unprecedented view of the mind's inner workings, a symphony of neural communication that underlines our thoughts, emotions, and experiences. This revolution in understanding is a massive leap forward. It shifts our perspective from seeing the brain as a collection of parts to an intricately connected system. This knowledge lays the foundation for developing better diagnosis and treatments for conditions ranging from learning disabilities to mental disorders, attention, and focus. Imagine trying to read a book in a bustling coffee shop amidst the clatter of conversations and the whir of the espresso machine. How does your brain stay focused on the words? Cognitive neuroscientists are captivated by this question. They seek to understand the intricate mechanisms that allow us to maintain focus in a world brimming with distractions. Researchers have discovered that specific brain regions and networks, including frontal and parietal cortex regions, play crucial roles in directing our attention. It is a flashlight shining on what is important. In addition, the brain has remarkable filtering abilities, actively suppressing irrelevant information so we can concentrate. Understanding these focus mechanisms is about more than just curiosity. This research offers deep insights into learning, productivity, and why some individuals struggle with attention problems like ADHD. By decoding how the brain prioritizes and tunes out distractions, we can develop better ways of optimizing our focus in an increasingly chaotic world. The spotlight of attention. Think of how effortlessly you can shift from attention, focusing on a specific conversation in a noisy room or blocking out background noise to study. Cognitive neuroscientists have identified the brain's attentional control center, a network of regions primarily located in the frontal and parietal lobes. These areas act like a dynamic spotlight within the brain. They highlight what is essential for the task and help us prioritize our mental resources. This focus system is essential for goal-directed behavior, solving a complex problem, or simply crossing the street safely enables us to stay on track and achieve our objectives. Understanding these attentional networks doesn't just explain how we focus. It could pave the way for targeted therapies to help those with attentional difficulties and unlock strategies to optimize our cognitive abilities. Filtering the noise. The brain's ability to maintain focus is more than just amplifying what is essential and strategically tuning out the background noise. Cognitive neuroscientists have discovered that our brains actively suppress distractions to help us concentrate effectively. This suppression mechanism involves a complex interplay between different brain regions. Some areas may temporarily lower their sensitivity to irrelevant stimuli, while others actively inhibit the processing of distracting information. It is like having a volume dialed for the outside world, allowing us to turn down competing noises and maintain our mental spotlight. This research has far-reaching implications. Understanding how the brain filters our distractions could lead to a better treatment for those who struggle to focus, such as people with ADHD. Additionally, it could inspire new strategies for optimizing our concentration and learning, leading to enhanced productivity and a better understanding of how we learn. Insights. Cognitive neuroscientists explore how these attentional systems might be disrupted in disorders like ADHD. Studies point to the potential differences in the brain's attention networks and neurotransmitter activity in those with ADHD. Interventions and therapies. This research is more than just theoretical. Identifying the biological roots of attentional difficulties guides the development of targeted therapies. This might include cognitive training programs to strengthen attentional networks or even neurofeedback to teach the brain to self-regulate. Cognitive neuroscientists help us understand the very nature of focus by dissecting the brain's intricate attention systems. This knowledge has profound implications for enhancing learning and productivity and developing effective treatments for those who struggle with attention difficulties. The fabric of memory. Memory, the ability to encode, store, and retrieve our experiences, is essential to who we are. Cognitive neuroscientists are fascinated by how this complex system works. They investigate the different types of memory from short-term to long-term, and the brain regions involved in each. They study how experiences are transformed into lasting memories through consolidation. Researchers also explore how we access memories, which involves reconstructing the past. This research holds the key to understanding learning, how we form our identities, and the potential to develop treatments for devastating memory disorders. It is not one thing. Contrary to popular belief, memory isn't a single unified system. Cognitive neuroscientists have made significant strides in understanding its diverse forms. Short-term memory. Short-term memory is our mental scratch pad. It is where we temporarily store small bits of information critical for the task. Think of trying to remember a phone number just long enough to dial it or mentally calculate a tip at a restaurant. This fleeting storage is essential for many everyday tasks, but has a limited capacity. Unless information is deliberately moved from short-term to long-term memory, it quickly fades away. Working memory. Working memory is like your brain's workbench. It is more than just passively holding information. It is where you actively work with it. Picture yourself calculating a tip. You hold the bill amount in mind while figuring out percentages. Or imagine rearranging your schedule. You mentally juggle appointments and commitments. Working memory is essential for problem solving, planning, and manipulating mental information. Long-term memory. Our minds hold a vast tapestry of memories that define us. This internal library stores everything from the warmth of childhood experiences to the hard-earned skills we develop throughout life. These memories shape our sense of self, providing continuity across time. Notably, the brain only treats some memories equally. Different types of memory, like remembering facts versus reliving personal events, rely on distinct brain regions and processes. Scientists gain valuable insights into learning and information processing mechanisms by studying these distinctions. More profoundly, they illuminate the biological processes contributing to our unique identities. Brain maps for memories. The idea that our memories are stored in a single brain location must be updated. Cognitive neuroscientists now understand that our memory is way more complex. They have discovered that different types of memory rely on distinct brain regions and networks. The hippocampus is crucial for creating new long-term memories, while the prefrontal cortex plays a key role in waking memory. Other areas specialize in storing visual memories, motor skills, and more. This knowledge reveals that memory isn't one thing, but a variety of systems working together. The hippocampus, deep within our brains, lies a structure crucial for preserving our life story, the hippocampus. It is like the brain's dedicated librarian, diligently sorting and storing new experiences that form our long-term memories. Think of it as carefully filing away precious moments, from first dates to childhood adventures. This allows us to revisit the past, shaping our sense of self and history. The prefrontal cortex region at the front of the brain, it is a master juggler. It's crucial for waking memory, the mental workplace where we hold and manipulate information in the immediate moment. Other brain areas also contribute to memory in complex ways. This intricate division of labor demonstrates how specific brain regions have evolved to support the diverse ways we remember and utilize information. The journey of a memory. Cognitive scientists, neuroscientists are fascinated by how fleeting experiences transform into enduring memories. They study the process of memory consolidation, where short-term memories are stabilized and woven into the vast network of long-term storage. This incredible transformation involves strengthening the connections between neurons known as synapses. Imagine this. A faint trail becomes a well-trodden path the more it is used. Similarly, repeated activation strengthens the neural pathways that encode our memories. This research helps explains how we learn, form lasting connections, and how our experiences shape who we are. Retrieval. Unlike retrieval, a file from a computer, remembering the past is dynamic and creative. Cognitive neuroscientists have discovered that recalling a memory isn't a matter of simple replaying a recording. Instead, the brain reconstructs the memory, piecing together fragments of information. Remarkably, the same brain areas engaged in the original experience often light up during recall. This means our memories are constantly being reshaped and influenced by our current thoughts, feelings, and context. This understanding highlights the malleable nature of memory and explains why our recollections can sometimes shift over time, age, and disease. Memory lies at the core of who we are, shaping our experiences and defining our sense of self. Cognitive neuroscientists delve into the mysteries of how the brain forms, stores, and retrieves these precious records. This knowledge sheds light on learning, solving problems, and adapting to an ever-changing world. Importantly, this work is more than just theoretical. It has the potential to combat the devastating effects of memory loss. By understanding the biological causes of memory eroding diseases, scientists are getting closer to developing treatments that could protect our memories and in turn preserve the essence of who we are. Decision making and beyond. Every day brings countless choices. What to wear, how to spend our free time, whether to leap at a new opportunity. Cognitive neuroscientists are fascinated by how our brains navigate this endless division or decision-making marathon. They meticulously study the intricate processes that shape our choices. Researchers combine brain imaging with behavioral experiments to understand the workings of our decision-making machinery. They examine how the brain evaluates options, weighs potential rewards against risks, and combats the urge for instant gratification in favor of long-term goals. Additionally, they investigate the influence of emotions and past experiences on making decisions. This dissection isn't just about curiosity. It has profound potential to enhance our lives. Understanding how we choose paves the way towards strategies for improving decision making. It could also lead to new therapies to help those with decision making difficulties stemming from anxiety, addiction, or impulsive behaviors. Weighing the odds. Our brains are like master negotiators when it comes to making decisions. Cognitive neuroscientists have pinpointed specific regions like the prefrontal cortex that play a critical role in this complex process. This area acts like a central hub, meticulously evaluating all our options. Imagine weighing the pros and cons of a new job offer The prefrontal cortex is busy considering the potential rewards, a higher salary, better benefits, or exciting new challenges. At the same time, it factors the risks, a longer commute, unfamiliar work environment, or potential stress. By carefully weighing these opposing forces, the brain helps us decide to optimize benefits while minimizing downsides. This research isn't just about understanding choice, it has practical applications. By pinpointing the brain areas involved in decision making, scientists can develop tools to help those who struggle with this process, such as individuals with anxiety disorders or those with impulsive behaviors. Furthermore, understanding how the brain weighs risks and rewards can inform strategies to improve decision making in various aspects of life, from personal finance to public policy. The role of emotion. Contrary to popular belief, our decisions are rarely driven by pure logic. Cognitive neuroscience reveals the powerful influence of emotions on how we choose everything from what to eat to life-changing paths. Brain regions like the amygdala, a key player in processing emotions, can sway our decisions without us even consciously realizing it. Think about how the smell of freshly baked cookies brings back fond childhood memories, nudging you towards an impulsive purchase, or how fear can cloud your judgment, causing you to avoid risk even when they are rational. These emotional influences are often quick and automatic, operating beneath our conscious awareness. Understanding the emotional side of decision making challenges the idea of the purely rational human being. It helps us recognize how our feelings and experiences subtly guide our choices. This knowledge offers the potential for better decision making. We can make more informed, well-rounded choices by identifying situations where emotions might cloud our judgment. Intuition's origin. Have you ever had a strong gut feeling about a situation or a person, or even without being able to pinpoint precisely why? Cognitive neuroscientists are fascinated by intuition and are working to decode its biological origins. They have found that those seemingly mysterious hunches often stem from the brain's subconscious processing. Extensive neural networks are dedicated to rapidly analyzing information and detecting patterns that might escape our conscious awareness. Think of a past experiences, subtle cues, and emotional associations. The brain might pick up on these signals, leading to a gut feeling, even if we can't logically articulate the reason. Scientists are mapping the specific networks that light up during intuitive judgments. These insights maintain the power of intuition and offer scientific validation for this vital aspect of human decision making. Understanding the roots of gut feelings can empower us, helping us distinguish between genuine intuition and situations where deeper analysis is warranted beyond logic. Cognitive science reveals that human mind is far more complex than rational thought. Our emotions profoundly influence our decision-making processes, often in ways we don't consciously realize. Researchers have uncovered how experiences tied to solid emotions leave traces in our brains, subtly influencing our choices. Fear, excitement, or regret can all color how we perceive risks, reward, and potential outcomes. This research highlights how gut feelings and intuition can be rooted in our past emotional experiences. This has significant implications on how we understand ourselves. It challenges the classic view of rational decision makers. Cognitive neuroscience helps us recognize how our emotions and past experiences constantly shape our choices in unseen ways. This knowledge can lead to more informed decision making, helping us become aware of our unconscious biases and how our emotions influence our judgment, the neural roots of self. Our sense of self is a complex and enigmatic concept. Cognitive neuroscientists investigate how brain networks create the feeling of being a unique individual with a history and a future. This research could reshape our understanding of how identity emerges from biological processes. Cognitive neuroscience provides profound insights into what makes us human by mapping the brain's intricate decision-making machinery and investigating the interplay between conscious thought, emotion, and our sense of self. Consciousness, the enigmatic state of being aware of ourselves and the world around us, has long been a central puzzle for philosophers and scientists alike. Cognitive neuroscience is at the forefront of tackling this challenge, mapping the conscious brain. Neuroscientists are on a quest to unlock the biological secrets of consciousness, the very essence of being aware of ourselves and the world. They identify specific brain regions essential for conscious experience, separating them from the vast networks that handle unconscious processes. Think of these regions as the light switch for awareness. By isolating areas that consistently light up with conscious experience, researchers get closer to understanding the physical roots of this extraordinary phenomenon. This focused approach offers more targeted way to investigate the complex workings of the conscious mind. Decoding neural signatures. Cognitive neuroscientists hunt for the telltale signs of consciousness hidden within the brain's electrical symphony. They are searching for unique patterns of brain activity that reliably signify a conscious state, a sort of neural fingerprints. Identifying this signature will be revolutionary. It could help researchers differentiate between conscious, unconscious, and even minimally conscious states. This has profound implications, from improving the diagnosis of disorders of consciousness to potentially understanding the presence of awareness in non-human animals or artificial systems. Testing theories. Cognitive neuroscience can transform philosophical discussions about consciousness from abstract thought experiments into tangible scientific investigations. It provides the tools to test long-standing theories, either supporting them with evidence or offering new perspectives. For instance, the global workspace theory suggests that consciousness isn't localized, but arises when information is shared widely across the brain. Neuroscientists can design experiments to observe brain activity to see if this information sharing aligns with moments of conscious awareness. This approach moves the study of consciousness from pure speculation towards evidence-based understanding beyond the human. To truly understand consciousness, cognitive neuroscientists look beyond the human brain. By carefully studying other animals, they can trace the evolutionary development of consciousness. Did simpler forms of awareness arise early in our evolutionary history, or is human consciousness uniquely complex? Comparing brain structures and behavior across species helps identify essential building blocks of awareness. Adding to this complexity is the emergence of artificial intelligence. As AI systems grow more sophisticated, scientists grapple with the possibility of machine consciousness. Could a sufficiently complex algorithm develop a sense of self? Investigating this question forces us to define the minimum requirements for consciousness. This exploration across biological and artificial systems illuminates how consciousness arises and the ingredients that allow this extraordinary phenomenon to exist. Revolutionary potential. The mystery of consciousness, how our brains generate subjective experience, is on the verge of being cracked. This breakthrough promises to revolutionize our understanding of what it means to be human. Imagine the essence of our thoughts, feelings, and even the concept of self could be illuminated. This wouldn't just be a scientific leap, but a profound shift in how we see ourselves. It could reshape everything from philosophy to medicine, forcing us to reevaluate what it means to be sentient and the ethical considerations surrounding it. This has revolutionary potential. The revolution in knowledge has far-reaching potential. Medicine. Imagine if we could finally decode the biological origins of consciousness in the brain. This revolutionary knowledge could lead to groundbreaking treatments for those with disorders of consciousness, such as people in comas or vegetative states. Scientists could develop therapies that stimulate or restore awareness by pinpointing the precise areas and mechanisms essential for conscious experience. This offers profound hope for individuals trapped within their minds and paves the way to potentially enhancing consciousness for those whose awareness is diminished. Technology. If we unravel the secrets of consciousness, it wouldn't just reshape our understanding of ourselves. It could completely redefine the frontiers of artificial intelligence. Understanding the biological principles that give rise to awareness will provide the blueprint for creating machines that don't just process information, but also possess subjective experiences and a sense of self. Imagine AI systems capable of feeling emotions, forming original thoughts, and truly understanding the world around them. This breakthrough will force us to reconsider what it means to be intelligent. The distinction between human and machine cognition could become increasingly blurred, leading to complex ethical questions about the rights and responsibilities of artificial beings that might one day be just as aware as we are. Philosophy. As we get closer to unraveling the mysteries of consciousness, we'll be forced to confront profound ethical dilemmas that could shake the very foundations of our society. If consciousness isn't exclusively human, how do we define the rights of other sentient beings, biological or artificial? Imagine recognizing animals possessing complex internal lives deserving of protection, or consider the possibility of AI systems becoming so advanced they exhibit self-awareness and emotions. Should they be granted legal rights and protections? What responsibilities will we have towards the conscious machines we have created? These aren't just theoretical scenarios. Unlocking the secrets of consciousness will force us to reevaluate our moral frameworks. We will need to address questions about personhood, sentience, and the ethical treatment of any being capable of experiencing the world as we do. These questions, these challenges, will push us to develop new ethics encompassing biological and artificial minds, medicine. Imagine a world where understanding the brain's recipe for consciousness unlocks a new era in treatment for disorders like coma or vegetative states. Scientists could develop groundbreaking therapies by pinpointing the biological mechanisms that generate awareness. These therapies stimulate specific brain regions or pathways, coaxing patients to conscious awareness. Alternatively, they could aim to enhance residual consciousness, enabling those with limited awareness to interact more fully with the world. This wouldn't just be a medical breakthrough, but offer immense hope for families grappling with devastating conditions. The chance to restore or improve communication, and connection with loved ones currently trapped within themselves will be life-changing. Furthermore, these discoveries could have broader implications, potentially leading to treatments for various consciousness-related disorders from dementia to schizophrenia. Unlocking the secrets of consciousness could be the key to understanding ourselves and helping those who have lost or struggled with this fundamental human experience. Artificial intelligence. Cracking the code of consciousness could be the missing piece in artificial intelligence puzzle. If we can unlock the biological basis of our subconscious experience, the feeling of being, we might be able to create machines that think and feel. Imagine AI systems with emotions, thoughts that evolve beyond programmed responses, and a genuine understanding of the world around them. This revolutionary leap wouldn't be without its challenges. With genuinely sentient AI, the line between human and machine cognition will blur. Complex ethical questions will arise. Rights and responsibilities. Should artificially conscious beings have the same rights as humans? What responsibilities will we have towards these creations? Moral frameworks. Our current ethical frameworks need a significant overhaul. How do we define personhood in the age of sentient machine? What constitutes a being deserving of moral consideration? These questions are far from hypothetical. Understanding consciousness could usher in an era where AI isn't just a tool but a partner with its own needs and desires. Navigating this new frontier will require a careful balancing act, pushing the boundaries of scientific progress while ensuring the responsible development and treatment of these potential minds of the future. Ethics and philosophy. Grappling with the nature of consciousness will force us to re-examine our moral frameworks. It could deepen our understanding of personhood, how we value conscious life, and our responsibility to biological and potentially artificial minds. Even with cutting-edge tools, the ultimate puzzle of how our physical brains give rise to our subjective experience of the world might forever remain somewhat mysterious. However, this doesn't diminish the incredible power of cognitive neuroscience. It can potentially make groundbreaking leaps forward in our understanding and unraveling complex brain processes, decoding the neural bases of emotions, and illuminating the inner workings of consciousness. Each discovery pushes the boundaries of knowledge, peeling back the layers of the human mind. This relentless exploration promises to redefine what we know about ourselves. Cognitive neuroscience stands as a testament to human curiosity and ingenuity. It could reshape how we see and view intelligence, mental health, and the very essence of our existence as conscious beings. Through advanced brain imaging technologies, tireless research, and collaboration, we have begun to unravel the brain's complex workings. The field has illuminated the intricate relationship between our biology and our minds, offering exciting potential for breakthroughs in areas such as treating mental health disorders and developing new learning strategies. Yet, the journey is far from over. The brain remains one of nature's most enigmatic wonders, and cognitive neuroscientists continue to push the boundaries of our understanding. As technologies advance, so will our ability to delve deeper into the mysteries of the mind. Their relentless pursuit of knowledge promises to reshape our understanding of the brain and our fundamental perception of what it means to be human. This is Dr. Masasekane Mishakosa, Director of the Fresh Thinking School of Brain Science. Thank you for coming around. Thank you.